Alright, so today we're going to go over the chain rule. Okay, so which states that, let's say, if y equals some f of u, and it's differentiable. Oh, I don't need where just yet. This is a differentiable function. Let's say, and u equals some g of x. If you wanted, you could rewrite it as y equals f of g of x. Okay. So if g of x is a differentiable function, clean that up some. Of x, then the derivative of f of g of x equals f prime of g of x times g prime of x. Okay, or in some cases, you may see if y equals f of u, then the chain rule is derivative of y with respect to u times derivative of u with respect to x.
Are we going to see it the second way?
The second one, the only reason I'm even introducing it is because it comes back for implicit differentiation, so you will actually need it later.
Y equals f of u.
Yep, so this you'll mainly use for implicit differentiation. But for the most part, you'll mainly use the first one. Be seen. Implicit differentiation. Okay, but the top one is the one that's most popular. Yes.
Okay, what's the difference when you take the derivative with respect to u and respect to x?
The only difference is when you, let's say if you have some function and you say, okay, instead of x squared plus 4 to the 5th power, I'll just make that equal u and kind of treat it like that. So we'll actually do both. So you'll see kind of how both of them would react. And you can pretty much pick which one works for you.
Right.
All right, so before we get to the example, might as well do a quick proof. Okay, so let's see if we let h prime of c equal the limit of f of x minus f of c all over x minus c as x approaches c. So instead of x and a's or x plus h and x, we're using x and c in the same spot. Oh, it's a little too bright. Was it better with the light or without?
I don't see the color. Better with.
With? Oh, okay. All right. So if we have y equals some f of g of x. Okay. So that means to find the derivative of y with respect to x would equal the limit Remember, we're going, instead of x plus h, we're going from h to c. F of g of x minus f of g of c all over x minus c as x approaches c. Okay. So if we multiply that derivative by g of x minus g of c over g of x minus g of c. Okay, so that gives us the limit of f of g of x minus f of g of c all over x minus c as x approaches c times g of x minus g of c over g of x minus g of c. Okay, so now we're just going to swap these two. Okay, so f of g of x minus f of g of c all over g of x minus g of c times, now we're going to have the limit of g of x. Because remember, this is the limit of this entire thing. So we're swapping those two, and then we're just applying the limit to both factors. G of x minus g of c all over x minus c as x approaches c. Okay, so if you look at this, this is actually the function or the derivative of f prime of g of c times, get that prime a little bit further over, g prime of c. Okay, so that's where the formula actually comes from. Yes.
When it comes time to like basically memorizing these formulas,
Mm-hmm.
do we necessarily have to memorize the proofs, or do we just need to know the overall rule?
Well, for the test, you'll have to remember the rule. I'll give you like 6 or 7 proofs and have like maybe 2 of them on the test. So you won't have to remember all of them. I'll give you like a week in advance, like a group to remember.
All right.
And these will usually be the shorter ones. I wouldn't have you do the ones that's like a page long. So. All right. Any questions? All right.
So,
Mhm.
I'm kind of confused what would happen to... Oh, so we don't even have to deal with the numerator in that function. You're just doing x minus c multiplied by g of x minus g of c? Or something like that? Or...
Which line are you
I'm trying
on?
to see, from the third line up, or like the middle line,
This one.
I'm trying to figure out how you were able to how you were able to multiply it to cancel out.
Oh, it didn't really cancel out. Because if you look at this one, let's say if g of x is some value. So let me use a different sheet. So if you had this one, let's say if we did let u equal g of x. Then this part here, oh, not this part, because all we did was just interchange these two. So that's how that moved over there. Because they're being multiplied, you can swap them over.
Which two?
Oh, sorry about that. Yep, you just swap those two. So that's how this ended up over here, and that ended up over there. So all we did was, let's say if u equals g of x just for that part. Uh-oh. There we go. That would give us the limit of f of u minus, let's say some u of c. F of u minus f of, let's say, c is equal to some constant. F of c minus, let's see, u minus c. as x approaches c. So remember, this is just our h.
Right.
So this is like saying f of x plus h minus f of x all over h.
Yes.
So when we do that, that would have just been our derivative. But here, this is just f prime of u, or f prime of c actually, since we have an actual value. When we have just x and x plus h, then that would have been just f of x, f prime of x. But since we have an actual value, now that becomes f prime of c. Okay. But now that we have this g of c, we just substitute that with f prime of g of c.
Okay, I can kind of see where you're coming from with that. I'm just trying to understand.
I know it's kind of tricky.
I'm just trying to understand, I think, the algebra behind it, which is where I'm kind of getting lost at, because I thought there should be, like, in the first set, there should have been f of g of x minus f of g of c, and then wouldn't it just be still multiplied by g of x minus g of c, since we're doing 1 over 1 with that?
You said
That's still in the middle line.
He's not actually multiplying it out. That's the thing. He's not
This
multiplying the g of x over. He's trying to see.
oh, you're trying to see if those were multiplied
I
out?
thought you were trying to multiply those out.
Oh no, all we did was just move this over here.
Then once you have.
Yep, so now we have a limit that's a derivative. And when we move this x minus c over here, now here we actually have a g prime of c.
It's like when you multiply anything you multiply across. Instead of what he's doing, he's moving the denominators from one side to the other, just so that he can turn that side into its
Yep.
own side.
Right, I get each, like, flipping the denominator
Mhm.
between each side, but I'm confused, like, what would happen to the numerator, or if there is anything.
They're not doing
Oh,
it.
nothing happened to
Oh,
numerators.
okay,
So it's
yeah,
kind of,
I see what you're doing, yeah.
you see it? Oh,
Yeah,
okay.
ABCD, right.
Oh, okay, so it's kind of like x over a times y over b. You can just make that,
X over b.
yep, x over b times y
Yeah,
over a.
okay, there it was.
I know it's the way it's written, it's kind of
Right,
tricky.
you would just keep thinking, right.
Yeah.
Okay, that makes a lot more sense now, thank you.
No problem. Oh. All right. Any other questions on this one? All right. Move that over there. Okay, so for example, let's say if we want to find the derivative of f of x equals 3x minus 2x squared to the third power. Move that over a little bit. There we go. Okay. Now, so far we've been using just the power rule where you have like x to the third power or x to the 2/3 power or something like that. But now you have an actual function raised to the third power. So you do the exact same thing, but you just have one more step to it. Okay, so if you remember the chain rule, let's say, yep. F prime of g of x times g prime of x. Okay, so that's the chain rule. Okay, so now for that one, well, probably should use something different than f and g, but I'll change that to h, just to avoid confusion. Okay, so now using the chain rule, let's say h prime of x is equal to, we're going to get that 3, bring it down. So that's the derivative of that g of x. Okay, so we're going to bring that 3 down. 3x minus 2x squared, and we're going to subtract 1. Okay, so that's the same thing we always did with the power rule. We always brought the exponent down, then subtracted 1.
This is the f prime g of x.
Yep, so that's the f prime g of x. So if this is your g of x, we're just finding the derivative of that. So just like with the power rule, you just bring down the exponent and subtract 1. That's what we did here.
So we just find the derivative of what's outside of the parentheses and then find the derivative inside the parentheses?
Exactly, that's it. So once you find the derivative of the outside, now your g prime of x is just the derivative of what's on the inside. Okay. So that's going to equal 3 times 3x minus 2x squared times the derivative of 3x minus 2x squared. So derivative of 3x is just 3. Minus 2x squared, you're going to bring down the 2. 2 times 2 is 4. And subtract 1, so that's just x. Okay, so for this one, your derivative is equal to, and you can write it any order you like, 3x minus 2x squared.
So you don't want to actually, you know,
Oh, no, you don't have to.
you don't have to complete those.
Nope, you don't have to foil it and all that other stuff.
Yeah.
Nope, you don't have to. You're actually good there. I mean, you can if you want to. It's just extra
Is the
work.
homework asking for it all the way done out? I swear, because I've been getting screwed up on the homework.
Nope, actually, they will be just fine with it like
Some-
that.
Some questions on the homework ask us to leave it like that, but some of them actually ask us to.
Oh, they do?
Go all the way out.
Oh, wow, I didn't know that.
Because some questions says do not complete, and then some questions don't say do not complete, and you actually have to complete it. Not for this homework, but for the class. I had
Oh,
this-
you mean for the, trying to think what we go over last time.
I've had some for this class.
Quotient, that was like.
Yeah.
No, not this,
Oh, they had it for the quotient rule too?
Well,
for this class, I know. It's
like,
like-
Quotient
I-
was
I-
sucked.
Yeah, no, those are terrible,
This
just because,
quotient was
like you
sucked,
said, I could
yeah.
stop early on some of them, and some of them I had to go all the way through, or when it went
Oh,
to.
Yeah,
Wow.
it was on, what was it?
I remember
3.4.2,
Hmm.
for sure.
I solved
This is
it
the
all.
first program that had you go like all the way through. Normally, when you get to right there, that's enough.
I remember I solved it all the way out, and they're like, your answer is wrong.
That was like 3
Oh,
steps
yeah,
back
and
my
then
answer.
and then
I'm
I-
like,
that's what happened to me too. I solved it all the way out, and I got it wrong, and then after like, after you try twice,
Mhm.
and then it gives you the answer, and it shows like the big, like that, and I'm like, okay, well, I had it right, but yeah, I did it all the way, and they didn't want that. And then
Yeah,
in fine
that's-
print on top, it says, do not complete it.
Yeah, that's odd. It's the first time I've seen that. 'Cause normally they'll just have you put it like that and call it a day. All right. Okay. Oh, so let me see if we solve this using the same one. Fine. Derivative of, let's say, h of x is 3x minus 2x squared to the third, but instead we use u substitution. Okay, so that's just really this, where is it? The second one here. Okay, so in this case, we'll let u equal 3x minus 2x squared. That means the derivative of u with respect to x is equal to the derivative of 3x is just 3. Bring down that 2, you have 4x. Okay, so derivative of y with respect to x using u substitution is derivative of y, well I guess you can derivative of h. Clear that up. Uh-oh. Really? There we go. So derivative of h with respect to x is equal to, and that's about to break again. There we go. Derivative of h with respect to u, derivative of u with respect to x. Okay. So derivative of h with respect to u, remember this just becomes, I give that one. So h of x equals u to the third. Because remember, we just made that equal u. So derivative of h with respect to x, or h prime of x, is going to equal derivative of h with respect to u. So that's just going to be 3u squared, just applying the chain rule there, times derivative of u with respect to x. So our derivative of u with respect to x is 3 minus 4x. So that equals, once we replace our u back there, 3 times, oh, forgot I squared somewhere. Yep, 3u squared. So it's 3x minus 2x squared times 3 minus 4x. Okay. So you get the same answer. It's just a different approach to it. Okay. Like I said, this is kind of an introduction to it here because we will be using it later. For the most part, it's used, that's pretty common to do it this way. But if you want to do it this way, you'd get the right answer too.
So the bottom is what's respected to? So it's like derivative of h with respect to derivative of x?
Yep, so you have your h of x here. But if you let u equals x squared, your derivative of h with respect to, oh, u, sorry about that. Where is it?
No, you got it right.
Oh, yep, I got it right. Okay. Derivative of h with respect to u is just (3u squared), since you changed it into a u.
Right.
So since you have your 3u squared, that's your derivative of h with respect to x is dh du, which is that, times du dx, which is that.
Would you have any questions what that would say find derivative of h to respect of u equals 3x minus 2x squared to the third, and then u substitution? Wouldn't that make it 3u squared would just be the answer if that was the case? But you won't have a question like that, would you?
No, it wouldn't be a question like that. Because if they wanted, what's it, did you say h prime of u?
Yeah.
If there's no u, then you couldn't really derive it. And that's when you're going into like multiple variables and all that stuff. So actually your answer would be 0. Because everything other than u would be treated as a constant. So it's kind of a slippery slope there. But
At first, when I was looking at that, I got confused for a second because when you said replace the u,
Mhm.
I was looking at it like h to x equals u to the third, and then h prime of that would just be the u to prime of or the derivative of u to the third. But then I realized that it was h to respect of x.
Yeah.
I getting confused, and then I figured it out.
Yep, so like I said, it's really kind of the same thing. The only difference is you're turning the g of x into a u. So now you're getting the derivative with respect to u, and then you're getting the derivative of that u, which is basically the same as deriving the outside and the inside.
I got a question.
Mhm.
So like, if they have, like, m times v squared divided by r, and solve for respect to r,
Mm-hmm.
then you would treat like m and v squared like a constant, and then
Yeah, so, and I know which homework problem you're talking about.
Question on that.
Yeah.
Yep, so it's something like,
I have a problem with that.
negative mv over r squared or something like that.
It's MV squared.
Oh, MV squared.
Over R.
Oh, mv squared over r. Okay.
I don't think it was negative either.
Oh, it wasn't. Okay.
They actually have a picture of it. but-
And that was a what's it? H of something like that. I'll say f.
It was f of r,
It was f of r. Oh, okay.
yeah.
Okay. So when you have an r here, that's the only variable it recognizes. So everything else is treated like a constant. So your f prime of r would just be your mv squared would move up as if it were a 3 and a 4. It would just move right to the front.
Yeah.
And then you're just going to find the derivative with respect to r of 1 over r. Or r to the negative 1.
Which would be negative MV squared over R squared.
Yeah.
Yeah.
Or would it? Wait, what would that be? What would it be? I'm sorry.
No,
Yep, so you have
Yeah.
mv squared with respect to r of r to the negative 1. So using the power rule, that just becomes,
Negative MV.
yep, negative r to the negative 1 minus 1.
It'd be negative 2.
Yeah, which is mv squared times negative r to the negative 2. Or you can just make that negative mv squared over r squared.
Yeah, I stopped. I was like, I give up.
So when it's respecting to, but when we used to
Is that one
respect
on the
to
test?
x,
Hmm?
Is that gonna be on the test?
I don't know. I haven't even made it up yet.
when we respected it to x before, there were things that we did that would equal it right to 0. Like,
Mhm.
4x minus 3, in that case, the 3 would
Mhm.
just drop.
Yep, the 3 becomes 0.
Right, but if we didn't have respect to it, then.
Yep, so if you
Oh,
had,
because it's a constant that we're multiplying or dividing.
yep, exact. So if you had 4x minus y, then now that y would be treated like a constant. So derivative of y with respect to x, that y becomes, not y, let me use a different one. Let's say t. So if you use a t derivative of t, that t is treated as a constant because you're differentiating with respect to x. So the only variable you're differentiating is x.
Okay, so
Everything else is treated like a constant. So if you have, let's say, instead of y, let's say f of x. F of x equals, let's say 3x plus 4t. Now let's say 4t, let's say 3x squared and 4tx. Okay, so you have prime of x. Remember, that's going to be 3 times the derivative of x squared plus that 4t is treated as a constant. So that comes right out to the front just like the 3 times the derivative with respect to x of x. Okay, so anything other than x just comes right out to the front. So kind of the same way with this one. Anything other than r comes right out to the front because it doesn't even recognize it as anything other than a constant.
And what if it was just like, and if it was a numerical constant, you could just technically say it would be
Mhm.
x to the 0 or whatnot? Like if it was like plus 4, then.
Oh yeah, then that would just become derivative of this plus 0 because that 4 would disappear. So if you had just 4t, then that's the derivative of a constant. Then that derivative of a constant would just become 0. Because there's no x variable here to actually derive.
Oh, so it would just be then 6x. or-
Yep, it would just be 6x.
So that's the only reason why MV is still in there is because when you bring the R up,
Mhm.
it can't multiply with those. So it's the reason why that cannot be 0. It
Yeah.
just moves out.
Yep, that's it. Because the m and v are just constants. At least when you differentiate with respect to x. Now, if you differentiate with respect to v, the m and the r would come out. And then you just get the derivative of v.